inclination of a line. The angle that a line makes with the positive x-axis is referred to as the angle of inclination of the line. We can see here that the given line makes an angle of theta with the positive x-axis. Thus, theta becomes the angle of inclination for this line. We can see that theta changes as the line rotates about p. Note that as we rotate the line, the gradient of the line m also changes. Hence, there seems to be a relationship between m, the gradient, and theta, the angle of inclination. Let us investigate further. Let us take 2 points on this line A, x1, y1, and B, x2, y2. Hence the gradient m is equal to y2 minus y1 over x2 minus x1. From trigonometry, we have tan theta is equal to opposite side over adjacent side is equal to y2 minus y1 over x2 minus x1. Hence we see that m is equal to tan theta, where 0 degrees is less than or equal to theta, less than or equal to 180 degrees. When theta is equal to 0 degrees, tan theta is equal to 0. Also, y2 minus y1 equals 0, implying that the gradient m is equal to 0, 2. This is true for horizontal lines. When theta is equal to 90 degrees, tan theta is undefined. Also, x2 minus x1 is 0, implying that the gradient m is undefined too. This is true for vertical lines. It is also important to note that the angle is measured counterclockwise from the positive x-axis. Hence, in the event that we have a negative gradient, let us say m is equal to negative 0.5, let us find the inclination. We know that tan theta is equal to m. Theta is equal to tan inverse m is equal to tan inverse negative 0.5 is equal to negative 26,56 degrees. Therefore, theta is equal to negative 26,56 degrees. The angle of inclination is usually not negative. Therefore, we make the angle positive by adding 180 degrees to it. By doing so, we change the angle from the fourth quadrant to the second quadrant. Therefore, theta is equal to negative 26,56 degrees plus 180 degrees is equal to 153,44 degrees. Hence, we see that the negative angle in the fourth quadrant has been changed to an obtuse angle in the second quadrant. We can verify that the value of tan theta remains the same even after changing the angle. Tan 153,44 degrees is equal to negative 0,5. Also observe that the line, when rotated by 180 degrees, becomes the same line. We have established that m is equal to tan theta. Knowing the value of any one of m or theta, we can easily find the other. Let us take 3 points, P, 3, 5, Q, negative 2, negative 3, and R, 4, negative 3. Find the angle QPR. Let us view them on the graph. We can see that the angle QPR refers to the angle formed by the lines QP and PR. Let us represent this angle by theta. We first calculate the individual angles of inclination for the two lines QP and PR. For QP, m is equal to y2 minus y1 all over x2 minus x1 equals 5 minus negative 3 over 3 minus negative 2 is equal to 8 over 5. Hence alpha is equal to tan inverse m is equal to tan inverse 8 over 5 is equal to 58 degrees. For PR, m is equal to y2 minus y1 over x2 minus x1 is equal to negative 3 minus 5 over 4 minus 3 equals negative 8 over 1. Hence, beta is equal to tan inverse m is equal to tan inverse negative 8 over 1 is equal to negative 82,87 degrees. We add 180 degrees to beta to make it positive in the second quadrant. Therefore, pi 1 is equal to beta plus 180 degrees is equal to negative 82,87 plus 180 is equal to 97,12 degrees. We are interested in the angle pi 2, since the angles QPR, alpha, and pi 2 form the angles of a triangle. Pi 2 can be found as pi 2 is equal to 180 degrees minus 97,12 degrees is equal to 82,87 degrees, as pi 1 and pi 2 are angles in a straight line. We know that the sum of the angles of a triangle equals 180 degrees. Hence QPR plus alpha plus pi 2 is equal to 180 degrees. QPR is equal to 180 degrees minus alpha minus pi 2 is equal to 180 degrees minus 58 degrees minus 82,87 degrees is equal to 39,13 degrees.
Need more help? Subscribe to our channel. Can't wait that long? Ask Mesky to help you. And if the math
finally start mathing.